Since the exponential function and the log function are inverses of each other, right? We learned that in another video. It's not surprising that all of those properties of exponents that we learned in the very first video this chapter, there are ones that kind of mirror those properties that have to do with logs. And so today's topic, laws of logarithms. Okay? And so the first one goes like this. If I have two logs with the same base, and I'm adding them together, that's equivalent to taking the log of their product. Okay? And so we write this, or we say this in words, that the sum of the logs is equal to the log of the product. Okay? And so I'm going to just do a numerical example to show you how this helps, why it's important. So if I ask you, I want you to add log base 6 of 4 to log base 6 of 9. And you would say, whoa, I can't do that without a calculator. Log base 6 of 4 is asking me what power of 6 gets me to 4. I don't know. What power of 6 gets me to 9? But if we use this property, the sum of the logs is equal to the log of their product, well, now I know that the power of 6 that gets me to 36 is 2. Okay? So we can take what looks like a really challenging problem and change it to an easier one that we can solve without a calculator. Sometimes we'll have questions in our homework where instead of coming up with an answer, they'll give the directions that say, write as a single log. Okay? And so if that's the case, sometimes it will be something as simple as log base 5 of 4 plus log base 5 of 2, and really all they want you to do is write log base 5 of 8, and that's your answer. Okay? So sometimes your answers will be nice numerical values, and other times the best you can do is write it as a single log. Okay, so first property, sum of the logs is log of the product. Okay, the next one goes like this. Now we have logs of the same base, and this time we're subtracting them. Okay? And so when we subtract two logs, it's the same as taking the log of their quotient. All right? So we say in words that the difference of logs is equal to the log of quotient. Alright, so here's a numerical example that will hopefully make sense to you. If I have log base 5 of 45, again, don't know what that is, and I'm subtracting log base 5 of 9, another one, I can't tell you without a calculator what log base 5 of 9 is, but if I put them together and say, oh, that's the log of the quotient, 45 over 9 is log base 5 of 5, and that's simply 1. So that's an example of where this property makes a seemingly difficult problem into something much simpler. Okay, great. And then the third property that doesn't have a fancy name, and I like to refer to it as the launching exponent, okay, for lack of a better name, goes like this. If I have log base b of x to some power n, that's equivalent to n times log base b of x. So what we can see that happened here is that the n used to be an exponent, and for no apparent reason, it launches right down in front. Okay? And so how we can use this property, if we have something such as log base 3 of 3 to the 7th power, we can rewrite that as 7 times log base 3 of 3. And we know that log base 3 of 3 is 1, and so simplified, that's equal to the number 7. Okay? Here's an example with the natural log, because we need to do examples. If I ask you to find the natural log of e to the negative 1, remember that the natural log is log base e of e to the negative 1. So that exponent's going to jump right down in front, so I get negative 1 times log of e base e to the e of e. That's a mouthful. And so we know this part is equal to 1, and so our final answer is negative 1. Okay? So three properties. You need to be comfortable with them. You need to be able to take a problem and change it so that it's a single log. You need to also be able to manipulate numbers so that a difficult problem like this changes to an easy one. And then let's go ahead and do a problem where we work backwards. Okay? So sometimes instead of applying the property where we take a difference and write it as a quotient, or a sum and write it as a product, sometimes we have a log where they're all put together and they want us to split it apart. So let's see if we can do this problem. So let's say that I have log of the cube root of m over n. Okay? And your instructions are to write in terms of log of m and log of n. And this is another way of, if the problems we did up here we're writing as a single logarithm, as in this property here, this problem write as a single logarithm. Now what we're doing is we're doing the reverse. We're going to stretch it out. Okay, so we're going to rewrite this, and we're going to recognize that this is log of m over n to the 1/3. Okay, so the first thing we're going to do is we're going to launch that exponent, right? Right? And then we're going to split this up. The log of the quotient is the difference of the logs. And so we're going to get log of m minus log of n. Okay? And hopefully you can see that this reversed the process that we did up in the problems up here. Okay, great. You'll have some problems, bookwork to work on this tomorrow. We'll see you in class.